The influenza vaccine. Why doesn't it always work? According to the Centers for Disease Control article, Vaccine Effectiveness, published in 2018, the flu vaccine prevented approximately 85,000 influenza-related hospitalizations and 5.3 million influenza cases during the 2016-2017 flu season. Flu season, the period of time during which the influenza virus activity is at its highest, falls during the late fall and winter for the United States. This means that flu season is fast approaching and the time to get vaccinated is now, should you opt for that path. As a current medical professional, I have personally witnessed severe cases of the flu, to include those that result in death. My goal is to help my audience understand that influenza has a capability to be a very dangerous disease. The flu is a quickly mutating virus that can change significantly between the point of vaccine formulation and the point of vaccine dispersion. Because the decision on which flu virus strains to formulate a vaccine for must occur so many months in advance of the projected flu season, the influenza vaccine does not always work as well as desired. In this presentation, I'm going to begin by describing the influenza virus itself and how it modifies to increase its ability to hide from the immune system of its host. Second, I will discuss the types of flu vaccines currently available and how they work. Finally, I will address the process of vaccine formulation and why it does not always work. Back in 2009, during the swine flu scare, you may recall the virus being referred to as the H1N1 flu. But what does that mean? According to the textbook Microbiology: An Introduction by Gerard Tortora, Burdell Funke, and Christine Case, published in 2016, the influenza virus is comprised of 8 RNA strands. This is important because RNA strands tend to mutate or modify themselves at a rapid rate in order to prevent detection by the immune system within their host. HA spikes and NA spikes both stimulate the formation of antibodies, which allows the body to fight off the disease. There are about 500 HA spikes on each virus. Their function is to recognize and attach to body cells to be infected. There are 16 subtypes of HA spikes, 3 of which can infect humans. NA spikes number about 100 per virus, and their function is to allow the virus to separate from the cell after it's been infected. There are only 9 subtypes of the NA spikes and 2 strains that can infect humans. If you look at this diagram of an influenza virus, you can see these spikes here, and they are HA spikes, and you can see them attaching to the body cell. Now, the influenza vaccine. There are 2 types of the flu vaccine. Tara Sigel Bernard, writer for the New York Times, published an article on 15 November 2018 that explains the vaccine types and how to choose the best one. She explains that the primary factor when determining your vaccine type is age. The 2 types of vaccine are going to be trivalent and quadrivalent. They are about the same except for the fact that the quadrivalent has 1 additional flu B strain that's created in its formulation. So you've got 2 types of flu A and 1 to 2 types of flu B that are created in the formulation and used to make the vaccine. Now, the benefits of the flu vaccine are multiple. For one, you can prevent the flu. Additionally, it can reduce the chances of flu-related hospitalization, can also lessen the severity of the disease in those who get vaccinated but still end up getting sick. Finally, the vaccination can help prevent the spread of flu to others based on a concept called herd immunity. Herd immunity is a phenomenon in which a majority of a population is vaccinated against a disease, which then greatly limits the spread of the disease by lessening the percentage of the population able to support or carry the disease. Now, there are a few misconceptions about the flu vaccine that need to be addressed. First, the flu vaccine does not give you the flu. It takes about 2 weeks for the vaccine to trigger the immune system to create antibodies. The flu vaccine is comprised of dead flu viruses or viral proteins that allow the immune system to create antibodies against the disease. This process can result in side effects from the vaccine, such as body aches, fever, and runny nose. These are all annoying side effects, and they can look a lot like the flu. Now, the vaccine formulation. So studies conducted by the Centers for Disease Control show that 40 to 60% rate of effectiveness is achievable with the flu vaccine. There are 2 factors that are going to influence this effectiveness. First, those with a compromised immune system or a pre-existing health condition, and those who are either very old or very young have a weaker immune system. And for these people, the vaccine can be less effective. The second factor is the match between the virus used in the vaccine formulation and the virus actually circulating in the community during flu season. As I mentioned earlier, the influenza virus mutates very quickly. This is where we talk about antigenic drift versus antigenic shift. Antigenic drift is small changes that occur during the process of virus replication. These changes can result in closely related viruses that will often trigger the same antibody immune response. Antigenic shifts, on the other hand, are sudden, large changes to the virus. An antigenic shift will usually result in a pandemic because it happens so fast that there are no antibodies capable of fighting off the virus. So if we look at this diagram here, this is our typical flu virus. These yellow triangles are going to represent the HA spikes. Now, here is a drifted virus. So the HA spikes have had a minor change in their appearance. They still look pretty similar, so they'll have a similar antibody reaction. Now with the shift, there's going to be a great change, and that change is going to result in a lack of immune response. So our yellow triangular HA spikes have modified to red squares. Not any immune response is going to be effective here. Now, to conclude, I just want to remind everybody that the thesis of this presentation addresses why the flu vaccine only has a 40 to 60% rate of effectiveness. The flu is a quickly mutating virus that can change significantly between the point of vaccine formulation and the point of vaccine dispersion. Because the decision on which flu virus strains to formulate a vaccine for must occur many months in advance of the projected flu season, the influenza vaccine does not always work as well as desired. In this presentation, I described the influenza virus itself, the types of vaccines available, their benefits, and their side effects, and the specific reasons that the flu vaccine does not always work at preventing the flu as hoped. Choosing whether to get vaccinated is a personal decision that requires some basic knowledge and research in order to make the most informed decision that you can. It is my hope that this presentation provided some education on the complexity of the influenza vaccine and why it's not always 100% effective. Thank you for watching.